Hi Debbie, I've just drawn out this electron shell basically. I'm just sort of explaining it to Oscar. Well, we're trying to work it out together as always, and I just wanted your help on it a little bit. Look, if I zoom in, from what I understand, I'm going to try and zoom in as much as I can. So we have an atom in the middle, which you can see here basically, and over here we have the K shell, so you can just see it there, and then it goes out KLM and N. On these shells, obviously on the K we only have 2 electrons, which you can see. Okay, so here's one and here's the other, and basically those 2 shells, on that first shell it has a 1s2, but I take it can have 2 electrons, so is that called a 1s2 as well, even though there's 2 electrons in that first shell? So I suppose that's a question. They go in a circular orbital, which you can see marked out in red, which sort of goes around here like that. Then on the L shell, which is out here, the second shell, we have a maximum of 8, which I've put here, okay? And of those, we have 2 s electrons, one here and one here. And then after that, we have the 6 p ones, 1, 2, 3, doubled 6. If I just go in there, you can see that, so I don't know if you can write it like that. Can you write it 2p and then 2 and 2p3, and up here we've got 2p2, 2p1. I'm not sure if you write it like that, but let me know. So on that shell we have a maximum of 8, so I'm hoping that and they go in this P shape. So also on that L shell, the 2 s electrons go in a circular form, so I'm hoping that that's all okay. So we have maximum 8, and then obviously if we move out to the M shell, we have a maximum of 18, which I take it as made up of the S shell, the S orbitals, so there's 2 s orbitals, one here and one here, and then we have the 6 p ones, 1, 2, 3, 4, 5, 6. Okay, I'm not going to go through all of this the whole way through. And then we would have the D ones. Well, I've only put 2 D ones, okay? So I take it that you could write those D ones as 3D and 1 and 2 respectively. So over here on this example, we have the 3D, and it got a maximum of 3D10. I'm not sure if that's right either. So there's a couple of questions there. I don't know if you could point us to a video. So but then if we look at a question, say calcium here with 20 electrons, okay, the answer is 4s2, which is put here. So but the way I was thinking of the electrons being made up is that there are here in the K shell, there's 1s, in the L there's also going to be a total of 8 and 2 respectively, and then in the M shell there is a maximum of 10 here, okay, just down here. So that would come to 20. So my point is why do you not write it out as 1s2, just like we've written it here basically, and then it should end up at 3d2, because we only need those 2 electrons. So we'd have 2, 8, and then you get these ones and these ones plus these ones, which brings you to a total of 10. But I understand the answer is this, so I'm a little bit unsure why it is that you suddenly jump up and use these electrons from the 4th shell, when realistically the 3rd shell still has these d orbitals left. Just wondering if you could explain that. I hope this this drawing helps anyway.